Okay, so thank you for the introductions. Now we can then move to the keynote presentation that will be introduced by Ariel Dinar.
Good morning, everyone. I have the pleasure of introducing the keynote speaker, but I want to make two comments before. One is that I'm very happy that we are sitting here to discuss facing the next generation of urban wastewater treatment. And I just want to mention that in my PhD dissertation a couple of years ago that I completed, the topic was about wastewater treatment and benefit cost sharing between the users. So I hope, I know that this keynote speaker is going to address issues of use of the treated water, but I hope that we are going also to have the opportunity to discuss it also during our discussions. Second, I also want to say that in my early career, and even in my late career, I learned so much from the published work of our keynote speaker that when we had a discussion in Rosenberg Forum Advisory Committee whom to invite, his name jumped immediately. So this is just the 2 more minutes. I have 5. So Dr. Manzoor Qadir is the Deputy Director of the United Nations University in Canada. And the United Nations University is a very famous institution that works on issues related to science, policy, and education. Manzoor has more than 30 years of experience in both developing and developed countries. He was able to impact directions in policy and in institutional and technical aspect of use of unconventional water resources, development and use. His work has been published, and his work is addressing issues both, as I mentioned, in the global south, in the developing countries, and in the developed world. We will enjoy, because I know what he's going to talk about, so we are going to enjoy a global perspective of the issues that we are going to discuss later today in our seminar. So please, Manzoor, the floor is yours. But you don't need that, right?
Thank you very much. Ariel, you actually raised a lot of expectations already. Before I start, I'd like actually to thank the Rosenberg International Forum and Borden Foundation for the invitation to speak at this workshop, where I'll cover overview of wastewater treatment challenges and solutions. What I'll do, I have divided my presentation into 2 parts. One will address what type of wastewater world we have, and the second will address what type of water world we need. If we look at the global picture, wastewater management is fragmented throughout the world. On one side, today we are here to discuss EU's Urban Wastewater Treatment Directive, which is focused on improving water treatment standards for better public health, environment. And we also have Clean Water Act in the US that addresses effluent limitation guidelines using water quality standards. And this act has been in place for more than 50 years. But if we look at most part of the global south, where the wastewater guidelines are there, but their implementation still remains a big question. And most part of the global south still faces disposal of and reuse of untreated or inadequately treated wastewater. Just wanted to share with you one of the slides from an extremely water scarce area, where this is basically a channel on the top right side of untreated wastewater. Farmers have connected these pipes with those small pumps, and they irrigate their fields regardless of its quality. And these pipes, in some cases, they run for more than half a kilometer. There is one key aspect of wastewater at the global level that has improved, and that is about the data itself. About 10 years ago, there were around 42 countries. They were reporting on how much wastewater they produce and how much wastewater they treat. But with the start of this global sustainability agenda back in 2015, there are more and more countries reporting on wastewater management. And as it stands, 140 countries and territories are reporting on wastewater collection and treatment, which constitutes 89% of the global population. But the situation is really grim if we look at the industrial wastewater, where still most of the industries, particularly in the global south, are able to throw their untreated wastewater into the municipal domestic wastewater channels. And that's where we end up in a mix of industrial domestic wastewater when it goes to a wastewater treatment plant, and if there is one in a city. Wastewater volumes continue to increase. There are four key drivers for that: population increase, urbanization, economic development, and improved living standards. And as it stands, 368 billion cubic meters of wastewater are generated worldwide, which is also kilometer cube. For those of you who might not be familiar with these complex terms of billion cubic meter or kilometer cube, this is the volume I'm talking about, 3 times the annual volume of water that passes through Niagara Falls. So here we are talking about large volumes of wastewater. And this is going to increase by the year 2050. We expect that 322 billion cubic meters of water will be produced around the world. The potential of wastewater remains largely untapped. And if we see the global picture, still 37% of the wastewater which is generated is not collected even and goes to the environment in untreated form. And if we look at the treatment stats, although they have improved over time, but still 45% of the wastewater goes to the environment in untreated form and creating water quality issues in major parts of the world. There is a deep divide across geographic regions. If we look at regions like North America and Europe, largely they are collecting and treating wastewater, in contrast to other regions like Sub-Saharan Africa, where hardly 20% of the wastewater is collected and about 10 to 15% of the wastewater is treated. Such divide even gets further deeper if we look at the country income groups, where low-income countries hardly collect 10% of the wastewater they produce and just treat about 4 or 5% of the wastewater that is generated within their boundaries. So there are multiple challenges to wastewater management, and the first one is the aging water and wastewater infrastructure. And this is not even common in the global south. We have seen the wastewater and water infrastructure is crumbling even in the developed world. More recently, the estimates reveal that even in Thames water, the water quality is really deteriorating. And that is because of the aging water infrastructure. And current estimates suggest that about 16 billion British pound would be needed just to ameliorate that infrastructure, which is around Thames water. Wastewater composition is also changing significantly. We were not seeing microplastics or contaminants of emerging concern 20, 30 years ago, but now there is a complex set of contaminants. And if we look at the treatment capacity of classical municipal wastewater treatment plants, they are unable to take care of these type of complex emerging contaminants. Climate change is fast-tracking the water quality deterioration because of the movement of flood water from one place to the other and introducing contaminants, those areas which were not even having those type of contamination. There are very limited financial resources and lack of skilled human resources, particularly in the global south, which are restricting the management options. So if we are not treating wastewater, so where does it go and who is affected and who pays the price? Eventually, there is a cost, regardless whether we treat it or not. And in those areas where wastewater is not treated, the populations living in the areas where untreated wastewater is either used or disposed of, they are paying the prices. And the studies have very clearly shown that waterborne diseases in those areas are more common compared to freshwater irrigated areas like gastroenteritis. And if we look at the health cost in those areas, which is much higher compared to freshwater irrigated areas. And what I just mentioned is that another challenge is that even the areas where the wastewater treatment plants are effectively treating wastewater, in fact, they are falling short of their efficiency because they are not, by design, they are not actually farmed to take care of complex human pharmaceuticals, complex products, microplastics, and stuff like that. And that's where there is a need to improve even those wastewater treatment plants in order to ensure that the quality of the wastewater remains effective to an extent where it can support the crop production, but at the same time, it should avoid transferring these contaminants to human food chain. By looking at the global picture, the world at large is off track in achieving SDG 6, which ensures water and sanitation for all, and in particular SDG 6.3.1, which deals with wastewater. So if we continue with the practices that we have and there is not much change, we definitely miss both SDG 6 and SDG 6.3.1 by the year 2030. So having said that, I'd like also to propose what we need and what can be done in order to turn the table and to really make a difference in this regard. We need to harness the full potential of wastewater for fit-for-purpose use. And when I say this, I aim at 4 critical sectors where treated wastewater could be used, and I use 4 A's for them: agriculture, aquaculture, agroforestry systems, and aquifer recharge. And if we look at the potential, and if we collect all that wastewater, treat it, reuse it, that is sufficient to irrigate 30 million hectares, even without dilution. So here we are talking about huge volumes of wastewater, and at the same time, if we treat, reuse it, we also avoid the health and environmental implications. But wastewater is not just a source of water, it's a rich source of nutrients as well. And if we look at the 3 major nutrients, nitrogen, phosphorus, potassium together, the wastewater has 8.3 teragrams of these three major nutrients. Again, 1 teragram is 1 million metric ton. And just for those of you who might not be even familiar with these units, so I'm talking about a mass of these nutrients which is comparable to 25 times the mass of Empire State Building. And removing these nutrients would also solve an environmental issue, which is eutrophication. Again, we don't end up wastewater with the water resource or nutrients. It's a rich source of energy as well. And there are more and more recent wastewater treatment plants which are becoming energy neutral, and in some cases even energy positive. So just to give you an idea how much energy is embedded in wastewater, if we have all that energy, that would be sufficient to offset the energy needs of 112 million households, and I'm talking about 374 million people. So either that energy could be used to make the wastewater industry completely energy independent, or that energy could be used to fulfill the needs of the households. And in order to move forward, what could be actually done to integrate circular economy applications? We can utilize biosolids, a product of wastewater treatment, into bricks and concrete. We can grow algae in nutrient-rich wastewater for biofuels, bioplastics. In drought mitigation practices, treated wastewater could be used, particularly in areas where which are extremely water scarce. It can provide ecosystem services by sustaining wetlands, at the same time supporting fish and shrimp farming. And it can also create an economic incentive, particularly for those industries who are treating and reusing the wastewater that they generate. In terms of policies, regulations, and institutional support, we have very limited political support to address wastewater management. The politicians still consider that it's more attractive to build a road or a bridge rather than putting a wastewater or investing on a wastewater treatment plant back in the backyard. So here there is a need for a change in the direction of how we can position better that wastewater management is a crucial aspect of environment sustainability. We need to integrate water reuse in water policies and practices, and at the same time introduce flexible policy options for promoting safe and productive use of wastewater. Another key aspect of wastewater is that large majority of countries even do not consider wastewater in their national accounting and water budgets. And that's why it just stays on the margins. And if we include wastewater in the national level accounting, then we'll be able to better address it as a part of the overall integrated water resources management in those areas. And the other key aspect is that the institutions responsible for wastewater management, they are fragmented with overlapping responsibilities. And these really need attention in order to really streamline wastewater management over a long period of time. There is also a need to introduce effective financial mechanisms, monetizing recovered resources such as biogas, fertilizers, or even reclaimed water. And we need to move from subsidies to full cost recovery, because that's where we are unable to move in terms of increasing the wastewater treatment capacity when we translate it to the global south. It can create employment opportunities as well. But the most important thing is engaging the private sector. And we have seen more recently in those countries where the private sector was engaged with public sector, it created a lot of opportunities and the speed of investing in wastewater treatment systems tremendously increased over time. While we are talking about these things, these interventions and potential solutions, they're not going to happen tomorrow. They will need actually years to be implemented. So what needs to be done in those areas where treatment is very low? We need to promote safe reuse practices, but at the same time, we should also look at those treatment plants which are non-functional, and we should try to fix those treatment plants first. At the same time, there are several wastewater treatment plants. Those are still effective. They are fully functional, but they are not efficient. The reasons are they are fully overloaded. Those were designed to serve a population, say for instance, 500,000 people, but now the population of the city has gone maybe to 1 million. So basically in those wastewater treatment plants, wastewater just comes in, stays there for a while, and just moves out, receiving some sort of primary treatment and stuff like that. So these wastewater treatment plants either should be expanded, or in those areas, another wastewater treatment plant should be installed. So these are the interventions in the interim we should be taking care of. Lastly, here is an opportunity for all of us to learn from and give, at the same time, input to the EU Wastewater Treatment Directive. I like it from one side that it introduces a phased approach, rather than creating a very beautiful picture that everything is really rosy and can be done overnight. It introduces a phased approach, like by the 2035, secondary treatment will be applicable to all our places, then 2039, tertiary, and then advanced treatment by the year 2045. And then it also emphasizes on effective monitoring system of public health parameters, chemical pollutants, microplastics, and AMR, antimicrobial resistance. Another key aspect is that it extends producer responsibility. And it suggests that they should be covering about 80% of the treatment cost, rather than that load should be covered by the public funding, while the remaining part is complemented by the national financing systems. So that's where I would like actually stop. Thank you very much for listening to my presentation, and I'm available to follow up the questions and comments you may have. Thank you.
So we have about 5 to 7 minutes for questions. So first of all, thank you very much, Qadir, Manzoor, for opening our eyes, connecting between past and future, and connecting between different initiatives, including the EU initiative or directive. So any questions that you may have, now is the time, and if not now, during the breaks. Anyone? Yes, Andrea.
Thank you for the wonderful talk. You spoke a little bit about institutional fragmentation. Can you break that down a little bit and talk about what that looks like?
Yeah. We have actually worked in several countries, and we go to a country and see who is responsible. And then we come up with at least 5, 6 federal ministries. And then if we drill it down to the local level, there are usually water and sanitation agency type of organization on one hand. But then they say, oh, we just deal with the wastewater which comes to us. We don't deal with its transportation and other stuff like that. The wastewater is being dumped into the groundwater by actually forcing the groundwater actually recharge and stuff like that. And nobody cares about that. And the organization which is responsible for the supply of water resources to the city, they say we just deal with that. So there are certain things. In certain cases, the wastewater system becomes a responsibility for 5 organizations in one place. And when you drill it down, you will realize that there are some areas where no one is responsible. So that's why there are overlapping responsibilities in one case, but at the same time, there are big gaps where nobody is responsible for that.
So fragmentation, like at one level of government, like at a federal level, but then we don't often have policies aligned then between like a local and a state and then, okay, thank you.
Thank you for the talk. I'm curious, you mentioned public-private partnerships, and I was wondering if you could give us an example of maybe where that's been successful and what characteristics lead to being able to deliver on those desired outcomes for those partnerships.
Yeah, there are many examples, and recently what we have seen is in Mexico. Mexico City used to release all the wastewater to a nearby Mezquital Valley. And it used to be the world's largest area irrigated by untreated wastewater at one place. So, and the issue was the government was unable to invest large-scale investment in terms of wastewater treatment. The tariffs were very low, and the farmers had the water supply and they were using it. That eventually then came up with the idea that why don't we involve private sector? And that's why now the private sector is responsible to collect the water tariff and the wastewater tariffs as well. So first, the private sector will recover all the funds that they have invested. With the major investment was done by the private sector, minor from the public sector. And then gradually that will be handed over to the government. But private sector will still remain actually part of that whole deal. So what has happened is the government was unable to do that, and there were large-scale environmental implications. So they brought in private sector. Private sector is also gaining out of that. But at the same time, the public is benefiting because they are now getting better quality of water. The farmers are getting better quality of water. At the same time, there is a cost recovery mechanism that is being now in place. So that's how, if we don't engage private sector, I've seen in other countries, the governments, they will put small amount of funding. They will start some work, and in best case scenario, they will install a wastewater treatment plant. And after a year, maybe 2 years, it breaks down. There's no additional funding to support that. And that's where then you go to those wastewater treatment plants. Those were designed with very nice ambition. The next government came in, those got deprioritized and nothing is working. By engaging private sector, it ensures that there is an interest from a party which would not let down this thing. And these are then bound by agreements to ensure that there is a long-term sustainability of those type of arrangements as well.
Yes, please.
Yeah.
One more question.
I have a short question. I wonder if these stricter nutrient removal requirements, such as the one imposed by the new European directive, do you think that this could discourage water use? I mean, that the high concentration of nutrients is one of the main benefits of water use, so I wonder if it would be practical to remove the nutrients if they are later used for agricultural irrigation. I know that the European directive takes this into account. If all the wastewater is used for irrigation, you can not remove all those nutrients, but the reality is that in a wastewater treatment plants you have different uses. So my question is if these stricter requirements in terms of nutrient removal could discourage water use. Thank you.
Yeah, that's a very actually important question and aspect. So what I was trying to suggest was that this is the potential of are the nutrients embedded in that. By no means I was promoting that every part of nutrient should be removed from that. That's one side. But on the other hand, it's very also important that we should remove significant amounts of these nutrients. Because if we don't remove those nutrients, then we will be continuing irrigating with that type of water, which eventually we will end up over a longer period of time, despite using treated wastewater, groundwater pollution. And we have seen that in different parts of the world. So a nice mix of that, considering the local conditions and fine-tuning the nutrient levels, is the best option in these type of situations.
Thank you. Okay, thank you very much. And I was instructed to stop the Q&A now. And any other question, Manzoor will.
Manzoor, thank you so much. I think it's a very complicated issue. And we have the fortune of having Julia Bucknell from the World Bank among us. Maybe later on in a discussion we can talk to see what fraction of funding that the World Bank gives, especially to the developing countries, is geared towards projects like this.